Alright, here is the library method, and we're going to talk about the target match tab. Alright, in the library method, the target match tab, let's talk about the purpose. The purpose of target match is to match hits that are found by some peak detection, whether it be TIC or unit mass deconvolution or accurate mass, sure mass, and to associate them with the target. So the quantitation method is involved here. The expectation is that you have used a library that has the targets, probably the same library you used as a reference library in the quantitation workflow. You're given a lot of options in the way that the matching between target method and the components that are found, library hits resulting from that, are matched. So you can insist that the targets have final concentrations and target responses. You can insist that the qualifier ions have been found, and even if the ratios are found, that's a very strict criteria. You can say, I only want to examine those components that have the target ion or have all the qualifier ions and their ratios. Also, I can say I must have that target within the expected quant target window. That makes sense. You can say I will match any hit where I see the same compound name or the CAS number. Here are the definitions of the estimation choices. Average response factor for all targets, and you can see how that calculation is done with the deconvolution area, or if you're using height, and how it assigns estimates to the components hits that have matched with the targets. Here are the formulas for average response factor of closest target and average response factor of all ISTDs. And one that I use, which is relative ISTD estimation. So you have a strong ISTD response, and that's similar to any compound. If you make that agreement, then you can use the response of that ISTD and then estimate with your targets, and you can see that estimate can be used with non-targets as well in terms of a semi-quant approach. And last, you can set your own response factor manually here, which we'll use as the multiplier. Thanks for your attention.